Today we're going to talk about rate of change and slope. This is lesson 4, and our essential question is how can you determine whether a function is linear or nonlinear? And how can you determine the constant rate of change for a linear function? So diving in, we're going to kind of review real quick what a function is. After our quiz, you should be feeling confident in knowing that for a function, this means that we have one output or y value for each input or x value, meaning for each x value, there's only one y value. A new term that we need to talk about is linear. And the basic definition for linear versus nonlinear is that linear functions have a constant rate of change. A constant rate of change. And what that looks like, I'll give you an example in a table format. I have x and y. I think that's all I need. If I had the x values of 3, 6, 9, and 12, and y values of 36, 30, 24, and 18. So this is a linear, I'm giving you an example of a linear function in a table format. And we know it's linear because if I look at my change of x, which we'll talk more about, but from 3 to 6, that's just plus 3. 6 to 9, adding 3 again. 9 to 12, adding 3 again. So that's a constant rate of change as far as my x values. Now let's look at our y values. 36 to 30 is subtracting 6. 30 to 24, subtracting 6. 24 to 18, subtracting 6. So since the change of x and the change of y are constant throughout each point, or going to the next point, then that means it's a constant rate of change, therefore linear. Now, let's look at nonlinear. Nonlinear. This is not a constant rate of change. So if I was given the table, if I have x and y, I need to extend that a little bit. And then x values of 1, 3, 5, and 7, with y values of 2, 9, 20, and 35. Okay, so looking at that, we know that going from 1 to 3 is plus 2, 3 to 5 is plus 2, and 5 to 7 is plus 2. So my x is still constant. But if we go from 2 to 9, that's plus 7, and then 9 to 20 is plus 11, and then 20 to 35 is plus 15. Because these are y's changes are different, it's not a constant number. It's not the same number each time. This is not constant, so it is nonlinear. And when we're talking about slope and rate of change, which is mainly what we're discussing today, we're really going to be looking at linear lines, linear functions. We can't really do slope for non-linear functions or sets of data that are not a function. We'll talk about more about that, but really what we're looking for is linear functions. So this item has to be true and this item has to be true. So I'm going to add in a new page. And we're going to talk about slope and what is slope. So we've kind of looked at what rate of change is. That's just what is the change for each point for X and Y. But really what the rate of change is our slope, or our slope is rate of change. They're the same thing. They're the same thing. So if you hear what is the rate of change, then that's our slope. If you hear what is the slope, that's asking for the rate of change. It's the exact same thing. We just use slope most often. Slope is represented by M. So if you see M in a formula or an equation, right now it is slope. So there are several ways that we can calculate slope. Really and truly, we've talked about rate of change. You can see there's a triangle. It's the change of y over the change of x. And I'm going to write denote change by a little triangle. That's just kind of a quick hand, but it is a very common quick hand thing that the little triangle or delta represents change. But we're talking about, as far as slope or rate of change, it's the change of y over the change of x. Or you can find that by saying y2 minus y1 over x2 minus x1. This is the slope formula. But really what slope is the rise. How are we rising over how many are we running? And we'll get into some examples of the different ways we can look at rise over run or using the slope formula. But there's several different types of slopes that we need to talk about first. Actually, there's 4 types. So I'm going to go ahead and draw our graphs. Okay. Actually, I'm going to go ahead and copy those. Copy, paste. So we have 4 different types of slopes. Also, be sure anytime you see a graph or you're making a graph, always label your axis. Always label your axis. So this is y, this is x. So, different types of slope. We have the first one I'm going to talk about is positive. It's going in the positive direction. This is positive. Oops. Going crazy with my clicking, sorry. Positive. And then that's, as we read from left to right, it's going in the positive direction, or it's going up and to the right, which are the positive values of x and y. So if we're reading from left to right and we see a line that looks like this, there we go, prettier line, then we should know that that is negative. This is the negative slope. That is our negative slope. Now, that's not the only directions that they can go. We can have some that look like this. And this is a zero slope or no slope because there is no change of y. When we're talking about slope, our change of y equals 0, as it's not going up and down at all. So if we looked at the slope formula, that would be 0 over the change in x, which anything divided by 0 is 0. So we have a 0 slope or no slope, but our slope is 0. And then we have one more, and it's this direction. This is called undefined slope. And the reason why it's undefined is if we think about the same thing as we talked about on our 0 slope of, okay, what is this really saying? Our change of y is all the numbers, but our change of x, there's no left or right. So our change of x is 0. So what that would be like is change of y, and if our change of x equals 0, that would be dividing by 0. We cannot divide by 0. That is always undefined. You cannot divide by 0. That's not possible. So that is undefined. So those are our 4 types of slope. But I wanted to go ahead and give you some practice or examples. If we looked at the table over here for our linear example that I gave, see if I can copy all of this. Copy. Paste. Okay. So we're going to talk about examples of how to find slope. Earlier, we said that this was a constant rate with -6 for each one at the bottom. And it was +3 on the top for each change. So if we do rise over run, or the change of y over the change of x, change of y over the change of x, then that would look like what our change of y is, which was -6, over our change of x, which we said was +3, and then we're going to simplify it. -6 divided by 3 would be -2, which would be our slope for this problem. Now, when you're given a problem where it doesn't divide out that pretty, or you have an improper fraction, always leave it in a fraction. When we're talking about slope, always leave in a fraction. And the reason being is because when we want to, if we wanted to take that slope and graph it, it's a lot easier if it's in a fraction form. If you start doing it in decimal form, you'll have to go back and convert it into fraction form. So just to start practicing, always leave our fractions or our slope in fraction form. Okay, so if we wanted to go ahead and do an example of, I'll even use the same points because we know it's the same answer, but I'm going to use the slope formula. So what I'm going to do is I'm going to take 2 points. I will say that this is 1. I'll do this in a different color. Do it in purple. This is 1 and this is 2. So if I was going to use the formula y2 minus y1 over x2 minus x1, I'm going to pick my y2. Oh, I'm sorry, I messed up on that of labeling which one was which. Let's see if I can get that to read. Oh, no, I'll just undo. So this is 1 as well. So this 3 is my x1, 36 is y1, 6 is x2, 30 is y2. So using the formula y2 minus y1 over x2 minus x1, I'm just going to put in those points. So y2 was 30 minus 36 over x2 was 6 minus 3. So 30 minus 6 is -6. 6 minus 3 is positive 3, and we get the same answer for our slope. I'm going to go ahead and at this point, that's pretty much all of the notes, but I'm going to go ahead and go over a couple of the practice problems on our PDF document. So if you'll go ahead and pause the video, go open the document and get to where you can work on that. We're going to work on a few of the problems there. Okay, so we remember that the key is posted. So if you want to work on the top part, you're more than welcome and check your work on the document. But I'm going to look at problems 1 through 3. So looking at a graph, I want to make sure we all remember how to write an ordered pair from a graph. So we're going to look at this first point. Looking at that, to write an ordered pair, we write the x value first and then the y value. Remember that this is your x and this is your y. X goes left to right, y goes up and down. So our x value is 3 and our y value is 2. Looking at the second point, our x value is 6. So I'm writing that with the parentheses. The x value, comma, and then our y value of 4. And I get that from knowing that I'm looking at, okay, what's my x value? I go over 6 to get to my x, and I went up 4 to get to this point. So that's where I get the ordered pair. We're going to practice doing it in slope, using the slope formula first, and then I will show you the rise over run. So this is my first point. This is my second point. So if I'm going to use y2 minus y1 over x2 minus x1, I apologize for the bell. Also, always write your formulas. It will help you tremendously if you don't just try to look at it and don't rewrite it. You will learn it and you will memorize it much quicker if you rewrite it for each problem. So please, please, please always write your formulas. But y2, so my second point, y value is what I'm looking for, and that's 4. So I'm going to say 4 minus, and then our first point, y value, is 2 over second point, x value, 6. First point, x value is 3. Now, I'm hoping that you can tell from the numbers, but remember what type of slope this is. Based on our left to right direction, it's going up and to the right. So that tells me it's a positive slope. It's going to be a positive slope. All right, so 4 minus 2 is 2, and 6 minus 3 is 3. So my slope is 2/3. My slope is 2/3. Another way we can look at it, and I'm going to use the highlighter for this portion, is I said, remember, rise over run also equals our slope. So our slope equals the change of y over the change of x, which is really what I use for tables. And then the slope formula of y2 minus y1 over x2 minus x1, which I prefer to use when I'm given points. And then we also said rise over run. And what that looks like, especially easier on a graph, is all we're doing is, okay, from how many points, from the first point to the second point, how many units did I rise? And what I mean by that is let's use a different color so we can see it. Went up 1, 2, and then how many units did we run, or how many units did we go over to our next point? So we went up 2 points, and we went over, units, and we went over 3 units, or ran 3 units. So our rise over run would be 3, doing it wrong. Our rise was 2 and our run was 3. So our slope is 2/3. Okay, looking at number 2. It's kind of hard to see where the points are, but this is a point, and is that right? No, that's not right. I don't have points. It's kind of hard to tell. We're going to pretend that our points are here, here, and here. You can pick either set of points to use your slope from, but it's going in the downward direction. So if we're going in the downward direction, what kind of slope is that? It is a negative slope. Negative slope. So you know that down here, your answer should at least have a negative sign. When doing the warm-up and the the exit ticket, put the negative sign with the numerator, the number on the top, and that will help you answer one of the questions. Okay, so if we were going to use rise over run or the slope formula, you can use either one. I'm going to use the slope formula. Let's do that. I'm going to do it over here. Remember, that's y2 minus y1 over x2 minus x1. Once again, I rewrite the formula every time I need it. So please, please, please rewrite the formula every time you need it. Okay, I'm going to look at this point and this point. You can use any of the three, pick two of them, and you can use them for this problem. So what are my points? My x value for that top point is -4, and my y value is 16. And then my x value for for the second point is 0, and my y value is 14. So my ordered pairs are -4, 16, and 0, 14. This is my first point. This is my second point I'm going to use today, or for this one. So my y value on my second point is 14 minus the y value for my first point, which was 16, over, and then the x value for my second point, which is 0, minus then my x value for my first point, which would be -4. Okay, so 14 minus 16 is -2. And then 0 minus a -4. If we are subtracting a negative, that's really saying addition. That's really like saying addition. So 0 minus a -4, because when it's a negative, we're doing the opposite. Meaning I'm not subtracting, I'm adding. So 0 plus 4 is 4. And that simplifies down to, because we always, always, always simplify, 2 divided by 4, or if we took both of those and divided them by 2, it'd be -1 over 2, which is our slope. If you wanted to use the rise over run method, you rise, you're going down 1, and we denote that by a negative. So going down 1, and you're running 1, 2. Running over 2. So same thing, rise over run would have us equaling -1 over 2. So same thing, we can find slope either way, or any of the ways we've talked about. Okay, based on our notes, you should be able to tell me what number 3 slope is without any math. So I'm going to let you work on that one. And then let's work on, we're going to do number 5. Number 5. And it's kind of hard to see the points, but I think we have a point here and here. Now, some of you might be asking, how do I know where the points are? And what the points are, if we can get in real close, is where it crosses the corners. of the X and Y grid. So it crosses both the corners there, doesn't cross there, doesn't cross a corner set until here and here. So that's how I know where my points are. Okay, so looking at, I'm going to pick a different point. I guess I should read the question. Lainey set up a lemonade stand. The graph below shows the amount of money in her cash register with respect to the number of customers Lainey has served. Find the rate of change. So what we're just finding slope. Remember, every time we see rate of change, that is slope. Okay, what are our points? So our X value, how many did we go over, is 0, but we went up 3 points for that one, or 3 units, 3 squares. We went over 4 and up 6 on this one. And over here we went up, or over 8 and up 9. So those are your points. Once again, you can pick either 2 of those. You could pick this one and this one, or you could do this one and this one. I would always pick from left to right though. So I'm going to say that this is my first point and this is my second point. That's what I'm going to do. So y2 minus y1 over x2 minus x1. Once again, reminder, always write your formulas. Okay, so if I'm going to find my y value of my second point, which is 6, minus the y value of my first point, which is 3, over x value of my second point, which is 4, minus our x value of our first point, which is 0. So 6 minus 3 is 3. 4 minus 0 is 4. Luckily, we do not have to simplify. We can't get those down any further. So our slope is 3/4. But the rate of change is, since it's a real world problem, we know what that 3/4 represents. That means that it's going up. Her amount of money, if we did a slope in money, would be $0.75 or 3/4 per customer. But as far as slope, we like to leave it in fraction form. But what the slope represents is that for every customer she gets 75 cents more. So she's probably selling her lemonades for 75 cents. Okay, so find the points again on 6 and 7, and looking at 8, let's see. Looking at 8. Okay, so this kind of talks about, brings up steepness. How steep is it versus, which is how big is our y versus how big is our change of x. That's kind of what you can use to help you. Our rate of change, saving $11 every 3 weeks. So that would look like 11 over 3, $11 per 3 weeks. And this one would kind of be, I'll just give you a hint. It's line C. Compared to our other lines, the one that most accurately represents it is line C. Okay, so you can finish these practice ones and then work on your independent activity and your exit ticket, and that is slope. So remember that slope and rate of change are the exact same thing. Remember our 4 different types of slope: positive, negative, 0, and undefined. And remember that the different ways you can find slope, either through the slope formula or using rise over run, or just counting the change of y over the change of x.